Yeah, hi guys, we are the Exodus, and I'm Mariana, here's Shaza, Julian, and Godong. So our narrative is about space travel, and space travel is hard. So first I'll be explaining to you our scope. Firstly, we'll be discussing about how many dangerous asteroids there are. Secondly, what is the effect of asteroid on Earth. Thirdly, if where can humanity go then? Fourth, can we survive on Mars? Fifth, how do we get there? And sixth, what do we do there when we reach Mars? So let us watch a short video first.
Unfortunately, Mars is actually a cold, radioactive desert where the ground is poisonous and breathing is impossible. Mars is awful. You almost certainly don't want to go there. The pioneers doing the hard work on Mars will have an intensely stressful life filled with incredibly challenging problems never encountered before.
Okay, now that we've seen why Mars may not be a good idea for us to go, ladies and gentlemen, welcome on board our BFR rocket with Robert, our scientist in charge. The captain has turned on the fasten seatbelt sign. Please take your seat and fasten your seatbelt. And also make sure your seat bag and folding trays are in full upright position. So on behalf of the captain and the entire crew, welcome aboard BFR rocket flight number 1048, non-stop flight service from Earth to Mars. So let us rewind a little bit. Why are we transporting to Mars? Why Mars? So our main reason of transporting to Mars is due to the incoming asteroid impact that can destroy humanity. So how many dangerous asteroids there are on Earth? Before we jump into how many dangerous asteroids are there out there, do you guys know what are asteroids? So there are millions of them. They are basically just rocks, and there are no regular shape to it. So they range in size from 1 meter to larger than 100,000 meters. They are also made of the same rocky or metallic materials. So where do they come from? The prominent ones come from a series of belts between Mars and Jupiter, occasionally intersecting the Earth's orbit due to external influences. Gudong will now explain more about asteroids.
Okay, thank you. Okay, asteroids are dangerous stuff, and hence NASA have set up satellites just to detect these potential planet killers. For the past few years, near-Earth objects have been recorded. This graph shows the discovery of asteroids. So far we have managed to discover most of the smaller asteroids, but larger asteroids are being discovered every year. Earth is no stranger to asteroids, as if you remember an event 65 million years ago, an asteroid impact wiped out dinosaurs. Some of these asteroids can even explode just a few miles near Earth. An incident in 2013, there was an asteroid which exploded near Russia, and it has left 1,500 Russians to seek medical attention. Okay, to show how asteroids impact will affect Earth, it will hit Earth. This you can see at this table. This shows a general trend that as asteroid size increases on the left, the frequency of asteroid impacts decreases. For catastrophic events with objects having diameter of more than 10 km, like on the extreme top right, the time between the impacts is at least more than 1 billion years. The last catastrophic event was around 65 million years ago. But are we truly safe? What will actually happen if an asteroid hits Earth? What will you do? From the limited data points, luckily, that Earth has experienced, scientists have plotted an hypothetical graph showing the relationship between asteroid size, recurrence, fatalities, and the area affected. Similar to the graph before, large asteroids occurs rarely, once every 100 million years or even billions of years. But the effect, if it's at large asteroid size, and as the large asteroid size occurs every 100 million years, the fatalities will be hundreds of millions or billions, and the regional area affected will be global. And it's a possible extinction level event. And just like every natural disaster, there is also a disaster scale for asteroid impacts. This is the Torino scale. The impact hazard associated with the near-Earth objects such as asteroids and comets. It is intended as a communication for astronomers and the public to assess the seriousness of collision predictions by combining probability statistics, kinetic damage potential into a single threat value. For example, if an asteroid is moving at a speed of very high speed, so the x-axis, the y-axis at the top, but the probability of impacting Earth is very low, so the bottom left corner, the trap value is only 0. But if the probability of it hitting Earth is very high, almost 1 at the top right, the threat level is now 10. Okay, now Shazza will talk to you more about the next part.
Yeah, so after, if Earth is no longer exists, so where do we escape? Like, there's a lot of other planets. So which planets are we supposed to go? So as you all know, there's 7 planets, but we only focus on Venus and Mars because, if it's too near to the sun, it's too hot. Then if it's too far from the sun, it's going to be too cold. So for Venus is a very hostile place. It is the hottest planet in the solar system. The surface temperature is hot enough to melt lead, and its atmosphere is thick that the air pressure on its surface is over 90 times that on Earth. So there's no oxygen at all, and it comprises 96% carbon dioxide, 3% nitrogen, and the others. Yeah. It famously contains a sprinkling of sulfuric acid, which forms dense clouds and is a major contributor to its brightness when viewed from Earth. So what about Mars? These are the properties of Mars. The surface temperature is 63 degrees Celsius, and the atmospheric composition consists of carbon dioxide, nitrogen, argon, oxygen, and also carbon monoxide. So from here itself, we can see that when compared to Venus, Mars is a better option because there's oxygen. Yeah. So in Mars now, it is dry and barren. Most of the water locked up in the polar ice caps. Evidence for water first showed up in 2000 when images from NASA's Mars Global Surveyor found gullies that appeared to form from flowing water. So from here you can see the 2 pictures. On the left is the Grand Canyon on Earth, and the one on the right is the Mars Nenedi Valley. Even though water is not actually seen, it is infrared from the landforms and similarity to Earth. So with water, there could be presence of life, hoping for humans to live in too. So with that, when we compare with Venus, Mars has a better environment for us to live in. So that makes us lead to the next question. Can we survive on Mars? Yeah. To survive on Earth, we have to consider the possible problems we will face. The atmosphere in Mars is just 1% of Earth's atmosphere and have 50 times more radiation than Earth. The soil also has no nitrogen, which is essential for farming, means no plant growth. So how do we even try to survive on Mars? So now I'll pass on to Julian. He will explain to you more about it.
Thank you, Shazia. So to escape from the imminent disaster, we will have to travel from Earth to Mars through uncharted space, just like how Christopher Columbus crossed the Atlantic in the 15th century. So how do we achieve this? Presenting our solution, the Big Falcon rocket, shortened to BFR, is the vehicle you all are sitting in right now at this moment. Do you all feel comfortable in it? It is going to launch soon. Yeah. In 2019, late 2019. Oh, now, okay. Yeah, we are actually traveling towards Mars right now. Okay. Okay. So the BFR is actually fully reusable. So this will give you a low cost, unlike in the early 20th century when the rockets are one use. So if you compare, for example, a brand new plane versus a plane that is reusable, it is obvious to see the tickets for which of the plane will be cheaper is the reusable one. Okay, and for payload to Mars, the BFR actually has a very high carrying capacity of 100 tons, and so it can support 100 people, including the life support systems, or 100 tons of cargo. And when it arrives at Mars, you aerobrake and enter at 7.5 kilometers per second, and you decelerate through friction with the Mars atmosphere. And when used on Earth for as a replacement for planes, it can actually travel from point to point in under half an hour. So what do we do when we arrive on a barren Mars? The initial colonizers will be living in small habitats or maybe even giant polymer domes. As mentioned, Mars has an atmosphere around 1% that of Earth. Hence, we have to create habitats that are pressurized and filled with an artificial atmosphere made of nitrogen and oxygen. To protect ourselves from the strong radiation, we have to cover the shelters with frozen carbon dioxide, which can be collected from the air, or we can go underground also. To survive, of course, we will need food. Martian soil is very poor and toxic, with almost no nutrients. To change it to fertile soil, we need to decontaminate it with enzymes and add various nutrients, but this is very expensive and energy depleting. Hence, we can choose to pursue aquaponics to increase our yield, our food yield. However, to make it habitable in the long term, we will need to terraform Mars to change both its atmosphere and biosphere to closer match Earth. Okay, we are now going to enter Mars orbit, so please keep your seatbelts fastened and we hope you had an educated tour. So now on to a brief overview of our story. In the year 2029, NASA has just detected that a 370-meter wide asteroid named Apophis is actually heading towards Earth. There are only 2 weeks left for mankind to evacuate before the collision. So what will mankind do, and what will Professor Smith and his son Robert face? So thank you, and we'll see you in our story on Mars. Here are some quotes from some famous people. The Earth is the cradle of humanity, but humanity cannot stay in the cradle forever. All civilizations become either spacefaring or extinct. I don't think the human race will survive the next 1,000 years unless we spread into space. And finally, I would like to die on Mars, just not on impact. Yeah, PS. If you stick to the end of our story, there will be an interesting surprise at the end. Right, thank you.